Welcome everyone. I am Shubham Karmakar and you are watching the Code with Singerji. Now we are continuing the lecture on the DSA using C and it is our day 4. And in last lecture we have implemented the array operations and today's lecture we will discuss about the linked list. What is linked list? Now you can see that the diagram I have given. In the data structure part, we have linear data structure, we have non-linear data structure. So we will talk about the linear data structure at first. And in linear data structure, we have static data structure in which we have the array. We have discussed about this part. This part is clear. But in the dynamic data structure, we have queue, stack, and linked list. And in the non-linear data structure, we have tree and graph. But before starting any other data structure, we have to complete the linked list, because using the array and the linked list, we can use any one of them. Using the array or the linked list, we can implement all these things. Okay, mainly queue and stacks can be implemented by both these things, and mainly the tree and graph are implemented using the linked list. So we have to know the linked list at first. Very important thing is that. Okay, so let's start. What is linked list? Now I will show you something. Okay, you will know that. You know that it is my YouTube channel, and you can see any other videos in here. Okay, so we will continue in a new tab. I will show you some pictures of linked list. It will be very much clearer to you. So I think this is the best picture for you. Now you can see here. Okay, you can see very easily. We have very many types of linked list. Basically 4 types: singly, doubly circular, singly circular. But we don't bother about that. We'll take the simplest structure, that is a singly linked list. Okay, so what is there? Please check this thing. Okay, so can I show it to you in a good manner? Okay, I will try. Okay, so I will show you here. Okay, look at here. It is the simplest structure of a linked list. What is that? We have some nodes here. The basic thing is node. As an array, okay, as in an array, suppose this is an array. Please see my drawing. Okay, here are some cells. Okay, what did it have? It have to allocate the contiguous memory allocation. Okay, so we will give some indices here 0 1 2 3 4 like that. Okay, ऐसे करके जाता है. Now if we consider the addresses, suppose we are giving here the integers only. Okay, if there is a character in the array, it is considered as a string. You know that. But in simple data structure, we have thought that it is integer here, and every integer suppose takes 4 bytes, only 4 bytes. Okay, so if it is called the base memory. If it is 100, then it will be 104. Okay, and it will be 108, and this series will continue because it is the contiguous memory allocation. Okay, now what is done in the linked list? Now you can see at first that we are taking one integer element only in one cell. Okay, suppose there is 0, there is 4, there can be 1, there can be 17, or like that. Okay, but if we consider the case of our linked list, so what will be there? Let's see. Here we have one node. This is called as a node. In each node there is two parts, mainly two parts. We can see greater than two parts, but we are telling about the basic thing. Okay, the first part is called the data part. This is the data part, and the second part is the next part or the address part. We are calling it the next part. Why next? I am saying, suppose in an array the first element is 1. So which element value we want to enter in that array, we will give the value in the data part in the linked list. And the address of the next data or the next node will be in the next part. How it is working? You can see here 4 nodes A, B, C and D. Okay. Now the whole thing is an node. This is a whole node. Okay. Now this A only is the integer value we want to add in the array. Suppose I am telling it as an array. So this is the integer part and this is the next part. That was the data part and this is the next part. This next part takes the address of the next node. The whole node has an address and that address is in the next part of the previous node. So how it works? There is no contiguous memory allocation. Suppose this is 100 address, this may be 1000 address. Okay, so it don't need to be a contiguous memory allocation. Maybe or may not be. Now what is the main part? That is, if we keep the address of the next node here, we start from the head, we give the head pointer. This is the head pointer. Okay, this head pointer takes the address of the first node, or the first node is also considered as the head. Okay, so this is the head and this goes to the, this next part takes us to the next node and the next part of the next node takes us to the again to the next node, then again and again and again, and at the last part of the last node next, the next part of the last node takes us to null, because after that node there is nothing. So the address of the address part of the last node takes us to the null here. It is the simplest structure of an linked list. Now what is the thing to notice? What is the profits and what is the losses? The losses are here, that if we took the array suppose of 5 length, okay, suppose of the 5 length, suppose it is of the length 5, okay, suppose 0 1 2 3 4 3 and 4, okay, 0 to 4, 5 length. So it will take how much of size? 4 for each. So 4 into 5 equals to 20. We can cover it by 20 only. But if here we use 5 node, we want how much memory? 4 for each data part, and suppose 4 for each pointer part. So 8 per node, so 8 into 5, 40 total. So it takes a large memory. Okay, now it is one problem here. And this memory thing is also benefited in the linked list. How? If we don't have the contiguous memory in a large scale for a large linked list, if we don't have a contiguous memory, we can randomly choose memory to store the elements. In memory context, it is a benefit also. Okay, that is the main profits and benefits we can consider here. After this, here are many profits and benefits also. How we can show you? Suppose I'm showing you. Suppose in a linked list, if you want to remove the B element. Okay, so what we will do? We will simply disconnect this edge. We will disconnect this edge and we will keep the address of the node, the next node, from here. All done. No extra traversing, nothing. But if we want to this thing, we can traverse. We have to traverse, but we don't need the swappings or like things I'm showing you. If we have 4 nodes A, B, C and D in the array A, B, C and D. Please don't mind for the handwriting. I am using the mouse. Okay. So if we want to remove the B part, what we have to do? After deleting B part, we have to take the C here, and the next we have to take the D here, and if the array is very large, it will take us to a very high time complexity and very much operations we have to do. As per same is in the case of insertion. We have to first swap here to here, then here to here, then one place is blank, then we can insert the new element. Okay, but this extra headache is not in the linked list. Okay, so these are main comparisons of array and linked list. You can read about it in the internet or from some books also. I think the basics are clear. In the next lecture, we will continue with the types of linked list. So till then, stay tuned, keep learning, and goodbye. See you in the next video.